Can you guess the output of this JavaScript code? Many beginners expect the output to be A, B, C, D because setTimeout has 0 milliseconds, but the actual output is A, D, C, B. So why does B run last, even though the timer is set to 0? To understand that, we need to understand one of the most important concepts in JavaScript, the event loop. JavaScript is single-threaded, which means it has one main thread that executes code line by line. It uses something called the CallStack to keep track of what is currently running. Let's start with a simple example. Console.log start. Function greet, console.log hello. Greet, console.log end. The output is simple. Start, hello, end. JavaScript runs console.log start, then calls greet, then runs the code inside greet, and finally prints end. At this point, there is no asynchronous behavior. Everything runs directly on the call stack. Now let's add setTimeout. Console.log start, setTimeout, console.log inside setTimeout, 0, console.log end. The output is start, end, inside setTimeout. Even though the delay is 0, the callback does not run immediately. Why? Because setTimeout is handled by the browser environment or Node.js environment, not directly by the JavaScript call stack. When JavaScript sees setTimeout, it registers the timer and continues running the next line. Once the timer is ready, the callback is placed into a queue, but it still has to wait until the call stack is empty. So setTimeout something 0 does not mean run immediately. It means run after the current synchronous code is finished and after the callback gets a chance to enter the task queue.
Now let's look at a promise. Console.log start. Promise.resolve.then callback console.log inside promise. Console.log end. The output is start, end, inside promise. Similar to setTimeout, the promise callback does not interrupt the synchronous code. JavaScript still finishes the current script first, but promises are handled differently from timers. Promise callbacks go into the Microtask queue. Microtask queue versus task queue. This is the key part. JavaScript has different queues for asynchronous callbacks. The two important ones for this video are Microtask queue, promise.then, promise.catch, promise.finally, queue microtask, Macrotask queue, setTimeout, setup interval, DOM events, some I/O callbacks. After the call stack becomes empty, JavaScript checks the Microtask queue first. It runs all available microtasks. Only after the Microtask queue is empty, it moves to the task queue. That means promise callbacks usually run before setTimeout callbacks. Main example breakdown. Now let's return to our original example. Let's walk through it line by line. First line, console.log A. This is synchronous, so it prints A immediately. Next, setTimeout, callback, console.log B. The callback is not executed immediately. It is registered with the environment. After the timer is ready, it will go to the task queue. Next, promise.resolve.then, callback, console.log C.
The promise is already resolved, so the .then callback is scheduled into the Microtask queue. Next, console.log D. This is synchronous, so it prints D immediately. Now the call stack is empty. JavaScript checks the Microtask queue first. The promise callback is there, so it prints C. After all microtasks are done, JavaScript checks the task queue. The setTimeout callback is there, so it prints B. So the final output is A, D, C, B. Now let's make it slightly more interesting. Console.log 1.
setTimeout, console.log 2, promise.resolve.then, console.log 3, promise.resolve.then, console.log 4, console.log 5. Try to guess the output. The output is 1, 5, 3, 4, 2. Why? Synchronous code runs first, 1, then 5. The first promise callback prints 3. Inside that callback, another promise callback is created. That new callback is also added to the microtask queue. JavaScript keeps processing microtasks until the microtask queue is empty, so it prints 4 before moving to the setTimeout callback. Finally, the task queue runs and prints 2. A common mistake is thinking that setTimeout 0 means the callback runs immediately. It does not. It means the timer has no intentional delay, but the callback still waits until synchronous code and microtasks are completed. Another common mistake is thinking promises run in parallel. The promise operation may represent asynchronous work, but the .then callback still runs on the main JavaScript thread when it gets scheduled. So where does this matter in real projects? It matters when you deal with API calls, UI rendering, button clicks, timers, animations, React state updates, loading indicators, async workflows, performance bugs. If you understand the event loop, you can better understand why your code runs in a certain order.
Let's recap. 1. JavaScript runs synchronous code first. 2. setTimeout callbacks go to the task queue. 3. Promise callbacks go to the microtask queue. 4. Microtasks run before tasks. 5. setTimeout with 0 milliseconds does not mean immediate execution. If this explanation helped, try to guess the output of this code and comment your answer.